Okay, so in this conversation, we're going to talk about polyatomic ions. Now, we've addressed polyatomic ions in the lab and also some in class. We're going to give a thorough introduction now to polyatomic ions, right? Sodium chlorite, for example, is used as a disinfectant in contact lenses, contact cleaning solutions, mouthwashes, and medication to treat ALS. So, chlorite, excuse me, is a polyatomic ion. So our learning goal here for this section is to write the name and formula for an ionic compound containing a polyatomic ion. So in general, polyatomic ions are they're a group of covalently bonded atoms with an overall ionic charge. That's really what they are. They often consist of nonmetals such as phosphorus, sulfur, carbon, or nitrogen, covalently bonded to a bunch of oxygen atoms. So you're going to see a lot of oxygen atoms here in polyatomic ions, and they usually have a charge of -1, -2, or -3. There's an exception. Ammonium is a polyatomic ion, and it has a positive charge, right? And there's no oxygens in it. So there's another exception that comes up frequently, and that is the hydronium ion H3O+. There's one more exception, which I'm not going to even give you because it's so rare. So in general, polyatomic ions are going to have negative charges. They're going to have negative charges, and they're going to have a charge of -1, -2, or -3 with a bunch of oxygen atoms, and we'll get to recognize those. Okay, so let's look at some examples. So here's some examples of a cast on a little boy's foot, it looks like, and it looks like it's got calcium in it, and a sulfate. It's got calcium sulfate in it, right? And can you see how the sulfate's got a -2 on it? It's got a bunch of oxygens. All right, fertilizer has a bunch of ammonium ions in it, right? And there's one exception, NH4+. It's got a bunch of nitrates in there too, NO3-. You can see a bunch of oxygens right there, and that's called nitrate. All right, so here's some examples and some names from your textbook, Table 6.8. Hydroxide, ammonium, nitrate, nitrite, and so on. Okay, I won't read all those to you, but this is an example from your book, Table 6.8. And one way to do this whole section is just simply to memorize those names, and that would work very nicely. Here's some examples now, looking at sort of help you appreciate how these words are made, how these things are named. There's a bunch of ions with 8 at the end: sulfate, phosphate, and nitrate. And look, they have different charges, -2, -3, and -1, or different number of oxygens, 3, 4, and 4, right? So the 8 simply must be memorized. Sulfate is SO4 2-, phosphate is PO4 3-, and nitrate is NO3 1-, right? But here's an interesting thing. If you take away one of those oxygens, so you see that this went from a SO4 to an SO3, right? And it goes to sulfite. And phosphite has one fewer oxygen than phosphate. And nitrite has one fewer oxygen than nitrite. Not sure if I said that right. Nitrite has one fewer oxygen than nitrate. There's some exceptions to those rules which I just described. And there's so few that they can simply be memorized. Cyanide and hydroxide are two exceptions to those rules. And let me now say that if you add a hydrogen to carbonate, right? So that's carbonate right there. We know from looking at our table. If you add a hydrogen to it, you can see that the 2- or the H+, that becomes only 1-, right? And we add the name hydrogen in front of it. So instead of carbonate, we call it hydrogen carbonate. Okay, and with sulfate, if we add an H+ to sulfate, then we reduce the charge by 1, so it goes from 2- to 1-, and we call it hydrogen sulfate. All right, so this is also interesting. You'll see that halogens have 4 polyatomic ions with oxygen. Instead of just having chlorate and chlorite, they also have perchlorate and hypochlorite, right? And the trend is like what you might expect. Chlorate's got one more oxygen in it than chlorite, but perchlorate's got one more yet. And hypochlorite has got one less yet. It's only 1 oxygen in that species. Okay, and those are for all of the halogens. All of the halogens obey those rules. So we could also say the same thing would go for, let's say, Brome. Brome for bromine, right? Bromate would be BrO3 minus. Bromite would be BrO2 minus, right? Just like chlorite, bromite would be the same thing except with bromine instead of chlorine. And you can imagine we can do the same thing with fluorine or iodine. Okay, and that's it for this part of the conversation. We're gonna this section we're gonna divide up into a couple different videos.